Okay, so basically the name of chapter or topic is not very much important because in many books,
What were again?
the name of this chapter like will be electrical charges and fields. In some book it was written electrostatic. So don't get confused in the name of the chapter or in the name of the topic, because this topic or this chapter is completely related to the basics of charges, right? We are not going to discuss about electric current, right? We are just talking
So
about the
in
charge.
the book, in our book, it's written electrical quantities. Is this correct?
Electrical quantities basically is a main section, and there are sub chapters or subcategories of that section, in which we are having a first topic which is known as electric field and charges. So in
Oh
electrical
yes, yes.
quantities, yes, so electrical quantities is a major part, and in that section we are having multiple small section like current electricity, practical electricity, electrical charges, like this, right?
Yes, yes.
So basically, this is also a type of a chapter or a section of electrical quantities, right? And in this
Yes,
chapter, we are only going to discuss about rest charges. We are not going to discuss about the movement of charges like the electric current or like electromagnetism or anything. We are just going to discuss about the rest charges like the magnets, right? And this section is much more like the magnetism, right? In magnetism we are having poles, and in this section we are having charges. So that is only a difference, right? In
yes, yes.
previous topic we are talking about the magnetic material and the magnets, and in this topic we are going to talk about the conductors and insulators and the charges, right? So
Yes, yes.
basically we know that there are two types of charges over there, and those two type of charges are, the first one is positive charge and the second one is negative charge.
Negative charge.
The charge on the battery, the charge on the cell, like in our daily life. So we are only going to discuss about the properties of these two types of charge, positive and negative, right?
Yes, yes.
And one more basic thing is, whenever we place these type of charges close to each other, we are not talking about a specific charge. We are just talking about journal charge, right? So we
Yes, yes.
write it as when two charged objects are brought close together. We brought these type of charges close together, so there will be a force, right?
Yes, yes.
Just like the magnet. So there will be a force between them. So that gives you the identification that there must be minimum two charges over there, right? That those charges
Yes,
are
yes.
going to apply force on each other. So again, the same concept we know, that same charge will repel each other, unlike charge will attract each other. The same like the magnet, same poles attract repel each other, and unlike poles attract each other, right?
Yes, yes.
So again, the same concept. If we are talking about same charge will repel, and unlike charges will attract.
That's right.
So this is very much easy and very much similar to the magnetism, only the concept is different. Where we are having poles in the magnetism topic, here we are having charges, right? And
Yes,
the SI unit for the
yes.
charge is, since we are talking about the charges, so the SI unit for the charge is coulomb. So coulombs is SI unit of charge, and we are going to use
What's the
C.
symbol? Okay.
So C is the symbol for coulombs, and that is the SI unit for charges. because there is a Coulomb's law for charge. That law is not included in O levels or IGCSE. That is going to be included in A levels. So upon the name of that scientist, they also replace the name of SI unit of charges, right? Because
Yes.
there is a law related to the charges given by the scientist Coulomb. So that's why we are using same name for SI unit. Okay, now if we are talking about some electrostatic properties, so we know that both charge will attract or repel each other just like the magnet, and there are two types of charges, one positive, one is negative, and there will also be a force and all these type like things. One more important thing is in this chapter, when we are talking about the materials, just like the magnets, iron and steel, we were talking in the last chapter. So basically there are three important things: steel, iron and magnet. So same for this chapter, we are having materials, and most of the materials are insulators. Like we talk about glass rod, we will talk about the silk cloth, we will talk about plastic rod, we will talk about
Yeah.
wooden block or rod, anything. So mostly we are talking about rest charges, because we know if we use conductor, so basically conductor conducts electricity. When it conducts
Ah,
electricity,
yes.
that is a part of current electricity. And since we are not talking about current electricity, so that's why in this chapter we only specific talk about insulators, right? Like plastic
Yes.
rod,
Yes.
iron rod, sorry, glass rod, like this. We will also discuss that what will be the effect on those objects when we uh, rub them with each other or by means of friction. But before that, let's talk about some basic journal properties like the magnetism. So we also have electric field, just like the magnetic field, right? So there is an
Yes.
concept of electric field, and again the definition remains same. You know the basic concept and basic
Yes. Yes.
definition of magnetic field: the region around the magnet where it can easily apply a force of attraction or repulsion on any other magnet, right?
Yes. Yes.
So same goes for electric field. So basically electric field gives you the concept of a region around a charge. It will exert force, right? I am not writing
Yes.
in detail attraction repulsion because you know the
Okay.
concept.
Yes.
And now we are again having the same concepts like the magnet. Let's suppose if we are having a positive charge and if we are having a negative charge. So we are having two different charges, right? And if
Yes.
we could draw a field for this, so when we are going to draw the field, to know
Yes.
about the direction of the field, that in which direction the field is going to move. Either it is going to move positive to negative, or either they are going to move negative to positive, right?
Like to pass. Yes.
So basically they are capabilities just like the magnetism. So the concept is very similar. uh, Electric field will move from positive charge to the negative charge, right?
Yes.
So
Yes.
it means that the electric field of positive charge is radially out, and the electric field of the negative charge is radially inward.
And so this is basically like north and south. So like the plus is like the north one
Ye-
like that.
Yes. We
Oh,
just
okay.
replace north with the positive sign, but
Yes. Yes.
the magnetic property is something different from the charges, right?
Yes.
Most of
Yes.
students mix this concept. They consider north as a positive, right? That is not
Yes.
a same thing, just for the reference, right? Concepts are same, properties are different. So basically for north pole, sorry, for positive charge, so field will be radially outward, and for negative field will be radially inward.
You know.
Radially out. and it will be really.
Invert.
And when they ask you about the direction of magnetic field, so that is also very simple. Field will always flow from positive to.
Negative.
From positive to negative charge.
Negative. Okay.
I am writing short. Plus VE means positive and E is negative. You may
Your
write
voice
it.
is lying a bit.
Okay, let me check. Okay, now is it clear?
Yes, yes. But as you talk, it goes back.
Okay. Actually, due to some weather condition, the signals are dropping.
Oh, okay, no problem.
So that is the issue. Let me know if now it is okay or not.
Yes, yes. Now it's like well.
Okay. So basically, I am writing a positive sign VE means positive and a minus sign VE means negative, right? So
Negative.
field will always
Yes.
flow from positive charge to negative charge, right? In short. Okay. Again, we are having a same electric field diagram, right? Let's suppose if we place two positive charge close to each other and we place positive and negative charge close to each other. So again, the same concept goes just like the magnet, right? When we place same poles of the magnet, so field pattern will be different. And when we place a different poles, so field pattern will be different. So same goes for the charges, right?
Yes.
And before that, let's write some basic property related to the electric field. There are some properties. And the properties related to the electric field will be like uh, in the start of this topic we write that whenever there are two charged objects, so they will exert force on each other, right?
Yes. Yes.
So when they exert force on each other, it means there will be some size of force, right? So
Yes.
how we identify the size of force, it depends upon the strength of the field, right? It depends upon the
Yes.
size of the force,
Yes.
it depends upon the size of the charge. So basically the size of the force on the field. So basically if there will be a stronger field, so it means there will be a large amount of force is going to be act on another charge, right?
Yes.
And again the same concept, we know that when there will be a weaker force or when there will be a stronger force, so stronger means, let's suppose if we decrease the distance between two charges, right? Let's suppose we are
Yes.
having two charges, one is positive, second one is positive, and here we can have positive, again positive. So you may easily identify that there will be a stronger field in each, and this will be right, because the distance
Yes.
between these charges will be decrease. So when charges will increase, so there will be a weaker force, or when the distance between two charges will decrease, so there will be a stronger force. So when we are talking about a stronger force, so it means that distance will decrease.
Okay.
These actual thing you don't need to write in detail or in the answer. These are points give you their concept during solving the question, and this loss hence increase. This will increase between the charge, right?
Yes.
Okay. Okay, now if we talk about the lines, so again the same concept, they will never intersect each other. So fields intersect each other, and the same concept when field lines are close to each other, so it means there will be a stronger field, and when field lines are away from each other, so that means
Yeah.
a weaker field, right?
Yes.
Okay. And one more thing, let's suppose if we are having a two positive charge close to each other, or if we are having opposite charge close to each other. Let's suppose we are having positive positive, and we are having positive and negative. So again we know the concept of the field diagram, that positive positive will repel, will be radiated outward like this,
Upward, yes. And the downwards will like that.
and radially outward from backside also. And this will be a simple north and south pole, it will move towards each other.
Yes.
Radially inward for the negative and radially outward for the positive. So this will be a field diagram for same charges and for unlike charges, right?
Yes. Yes.
So till now.
Yes. I mean, okay.
Okay, so this is a very basic concept related to the charges. We all things we studied for the magnetism, so all these things are also applicable for electrostatic concept of charges. Only the
Okay.
charges are different, only the terms are different, but the concepts are very much similar, right?
Yes.
Okay, and we know that when we would talk about conductor and insulator, so basically for conductor we know that they conduct electricity because they have free electrons, right? And what
Yes.
about insulators? They don't have free electrons,
They
or
don't.
they
Uh,
have free
they,
electrons?
they have free electrons.
Yes, because when we are talking about charges, so every body is a neutral body, right? Since if we consider our body, so our body contains also both charges, positive and negative. Each and every body contains both charges, right? But the problem is that the orientation of the charges is very much important. In conductor, electrons are free to move, so they can easily
Yes.
move from one point to another, so that's why they fall in the category of conductor. But in insulator they also contains electron, but the problem is that they can only vibrate about their fixed position, so that is the problem, they don't conduct electricity. That is the only difference between the conductor and insulator, that's why we use them in different materials. So in next class we will
Okay.
start with the insulators, because there are some examples related to that, that if we use a silk cloth with a glass rod, or a glass rod with some different material, so that is the concept. So we will discuss that also, because the process of induction is reduced from your syllabus. So that is a good thing. So we will also end up this chapter in next class when we also solve some questions related to electrostatics, right?
Okay. Yes.